Good afternoon, everyone. Thanks for giving us the precious gift of your time today as a busy 2020 winds down. My name is Doug Reichert, and I'm working here today with Adrian Patani to bring you this event regarding EDC 6. Our intent is to shed more light on EDC 6 as this important initiative has implications for all project stakeholders. I'm very happy to introduce our expert today, Mr. Adrian Patani. Adrian's an 18-year veteran of Trimble and has been engaged with DOTs and contractors around the globe during most of that time. He brings value to the DOT community with his experience and in-depth understanding of how infrastructure projects get designed and built. Having been an active participant in organizations like AGC, ARPA, AASHTO, to name a few, you may have seen one of his many presentations over the years. Please submit any questions you have during the presentation in the questions window, and we will commit to answering all of them via follow-up email. So let's turn it over to Adrian and let's get started. Thank you.
Okay, thanks for that, Doug. Can you hear me okay?
Yes.
Okay, perfect. Just wanted to make sure. So yeah, let's get started. So really, I guess the premise of this whole presentation just was to really talk about the Everyday Accounts initiative that the FHWA has recently announced, and in particular, the Everyday Accounts number 6. For those that aren't familiar with the EDC is, or Everyday Accounts initiative, it's essentially a state-based model that identifies and rapidly deploys proven yet underutilized innovations to shorten the project delivery process, enhance roadway safety, reduce traffic congestion, and integrate automation. Proven innovations promoted through EDC facilitate greater efficiency at the state and local levels, saving time, money, and resources that can be used to deliver more projects. But what we're focusing on today is a component of the 6th round of the Everyday Counts initiative. And Trimble's been involved with a number of these initiatives over the years, just because they are promoting innovation and technology, and that's obviously what Trimble really does focus on. So let's focus on the specific EDC 6 technology, which is the digital as-built. And by definition, the digital as-built is really, or at least the EDC 6 initiative talking about digital as-builts, is where you're using digital data such as 3D models to build road projects, effectively becoming an industry standard. Sharing the design model and associated digital project data allows agencies and contractors to streamline project delivery and contract administration and collaborate on challenges virtually before they get to the field. The digital information is further leveraged when the model is updated and other data incorporated to reflect the project's as-built condition for future maintenance, asset maintenance, and rehabilitation services. So really the core benefits that are associated with the digital as-built are your project safety, quality, and cost savings throughout the entire project lifecycle. And so fundamentally what we're aiming to do with this presentation is highlight essentially what a digital as-built is, how it can be used, and why you want to use a digital as-built in your 3D construction workflows. So why do we want to use digital as-builts? Let's consider some of the challenges we see in the industry. And again, Trimble has a lot of experience in the construction industry, a lot of experience in applying digital technologies to the construction industry. And as you can see on the graph on the right-hand side, a lot of other industries are incorporating technology and innovation. Construction is sadly lagging behind. And if we consider the 3 elements that we've highlighted there, they're the ones that I've felt are the most relevant for this digital as-built discussion. 40% of projects are over budget. 90% of construction projects are late, and 30% of those construction projects is rework. So you can understand, not having technology associated with those projects, applying technology to those types of projects has significant benefits and advantages. And that's really what we're going to help elaborate a little bit more throughout this discussion. So let's get on to the next slide. So, talking about continuing on with why you want to use a digital as-built. So you can't get to a digital as-built unless you've actually got a 3D model that's been used throughout the entire project construction lifecycle. There are digital as-built out there that may be like a 2D PDF or a plan sheet, which, or even such as a drone flyover or a finished surface with no underlying intelligence. But a 3D model, once you have that intelligence built into it, is so much more useful. And one of the things we wanted to talk about in this sort of presentation as well is we're leveraging the technology from the European market that has been using 3D models in construction for many years. The good thing is we're seeing a lot of this adoption, and we're going to talk about that in a second, across the US market. But one of the things we want to highlight is that this is a proven and tested technology. On the little diagrams we have down here, we have the traditional methodology, the traditional approach, where you're looking at over 1,100 drawings, and these are for real projects where they're actually designed and constructed. If we look at the right-hand side, where we actually applied the BIM 3D modeling workflow, the number of drawings for a similar type project was reduced down to 89, and that's a difference of 90%. That's a pretty staggering amount there. And that's, I guess the primary way that it does that is by informing all of the different parties, all of the different entities that are working on a complex infrastructure project. They're not trying to figure out what's happening with a 2D plan sheet or a PDF. They're actually able to look at a model and be able to interact with it, collaborate on that model, and then ensure that everyone has access to that model that need to throughout the entire life cycle. And of course, that's that same model that's going to become your digital as-built. So another little slide here on the BIM advantage. Change orders are a significant cost of your construction. And in our recent reports here, we're looking at an average of 19% of total construction costs using the traditional methodology. By applying the BIM 3D methodology, or essentially BIM workflow, that number by average gets reduced down to 77.5%. So if you recall, if we're referring back to that original diagram where we're looking at the cost overruns that are associated with with construction projects, we're able to have a significant impact on that number by simply applying this 3D BIM workflow, generating a 3D as-built, and that's not even touching on the operations and maintenance cost. That's a significant cost for your actual project once it's constructed. This is just the actual construction cost, so you can extrapolate some of those benefits throughout a total project lifecycle. So what we're also seeing, again, I touched on it earlier, is the accelerating adoption of digital construction in projects here in North America. And that's just purely because of those numbers we were just showing you. It's a known fact that applying these approaches are going to have significant benefits both to the owners, to the designers, and to the operators as well once you've got that project. So obviously we're talking about the FHWA and the digital as-built EDC6 that we're currently referring to. There's also other resources that are available. The aid, the federal, the FHWA Accelerated Innovation Deployment Initiative is there to provide funds, and the program provides funding as an incentive for eligible entities to accelerate the implementation and adoption of innovation in highway transportation projects. We're also seeing the Secretary of Transportation directed to provide $10 million from within the Technology and Innovation Deployment Program for Advanced Digital Construction Management Systems, consistent with the direction and supportive language in the House and Senate reports. And then we're also seeing AASHTO, which they're promoting e-construction nationally for the collection, review, approval, and distribution of highway construction contract documents in a paperless environment. All of this is mainstreaming technology for asset management, electronic as-built drawings, and quality assurance records. So, bottom line, there are resources out there, there are initiatives, and there is funding behind there for you to apply these innovative technologies to your construction project. So we've talked about why you want to apply digital as-built, but what exactly are they? At its core, the digital as-built is a digital representation of the constructed project. It effectively becomes a decision-making support tool that obviously provides optimal real-time information for your operators once the project is created. And it can only really do that because it's got the intelligence built into it from the construction life cycle. It's not just a flyover surface. It's not just a point cloud that doesn't have any data behind it. It's the projects themselves, and then all of the underground underlying information on utilities and metadata, and we're going to talk about that in a second, that enable that ability to be able to be used in operations and maintenance. And then, of course, inherently, the end goal is to be able to have that information available to IoT devices, to autonomous vehicles, to whatever else you want using that infrastructure, because they're going to be leveraging the intelligence built into that model and be able to extend the life cycle of that infrastructure project. So why do we want to use a digital as-built? To an owner, and what it lets them do is provide a greater level of detail and accuracy, and that's it gives them visibility into the project as well. It also means that at a contractor level, it empowers them to get better quality for a better finished product. They can do better bids because they've got more intelligent data that they can do better estimates in. And of course, that intelligence flows throughout the construction project as well. And we're going to touch on that in a few more slides. And of course, we're talking about the as-built. So you've got more efficient construction that are technologies that are using that 3D model throughout the whole life cycle, so that then when you do get to that digital as-built, it's got intelligence built into it. But it's also becoming a living record throughout the project life cycle, because you've got intelligence from the field that's actually been fed back into the model, so that then you're able to utilize that once it's been constructed. So how is the digital as-built used in construction? And one of the most simple applications of that is location and versioning of that model. In other words, how do we make sure that your machines that are actually out there constructing the project are using the latest model, or using the model that everyone else is using, versus the previous way they would have to run out there with USB sticks. What we're able to do now via the connectivity, which we're going to touch on in a second, is make sure that all of the machines have the latest version, everyone is working off that latest version, and you're able to ensure that by checking that you're able to disseminate that very easily because of the connectivity. And not only that, you're able to update the model in the office, and that office to field connectivity enables that digital as-built to become that living record, because those changes can then be sent out to the field with much greater ease. But then that also facilitates communication back to the model from the office, from the field itself. So, how else is the digital as-built used in construction? Visualization is a very powerful tool, and being able to see that in the field is something that is currently really isn't available. If you're out there trying to construct a project and you've got a 2D PDF and you're trying to visualize the 3D model, obviously that's very difficult to do. But with the tools that we have in place now, there's very sophisticated visualization tools where we can actually be out in the field and actually be seeing the same model that the machines are using to construct a project. And this example that we're seeing here, one of the simplest examples of the beauty of having that information was they were able to see that there was this structure or embankment that was actually extending much further out into the roadway than they thought, based on their designs. And as you can imagine, seeing a design on a computer screen has a lot of obviously restrictions, but being able to see that same digital design with the intelligence behind it in the field means you're much more empowered in the field to be able to see that, make changes, and make observations or things that you see in the field can then be modified on the design. So we want to talk about the intelligent as-built as well. I've sort of touched on it a little bit, but what that means is that data from the field or data from the project as it's been constructed is being fed into the actual model itself. Now, we can only really do that via connectivity, and I've got some slides on that in a second, but what that means is that you've got the machines out there not only actually creating the project and constructing the project, but they're actually using sensors on those blades of those machines to generate surfaces, which are actually being fed back into the model itself. So you're able to use that for progress mapping, for monitoring of a project as it's being constructed. But the beauty of that, all of that data intelligence is being gathered and entered into this 3D model, which can then be used for your operations and maintenance. So there's a win-win for basically the construction itself, but then also for the actual as-built too. So some of those, just to sort of elaborating a little bit further on that, if we're actually using that 3D model in construction, things such as compaction values can be recorded as the project is being essentially compacted. And again, those compaction values are going to be incorporated into that 3D model, or that digital as-built. Another very sort of simple example is things such as pavement thickness. At the moment, if you've got a project out there and you're going to mill a road, you have very little idea what the depth of that pavement is to get to a solid base. So you don't want to over mill, because obviously you'll get down too far and you could not have a strong enough structure to support the overlying material. But what if you could have access to that pavement depth and understand that when you're actually out there doing maintenance or operations on an existing project? You know exactly how thick that pavement is, so you can feed that 3D data into your milling machine to know precisely how far it can go down. And that's just one simple example of that. And that's just one advantage of recording that information, not only just the pavement depth, but of course you can have all the underground utilities and asset information that's embedded into that. So there's safety that's tying into that as well. So again, the benefits of being able to utilize that data during construction. So as far as post-construction, we've actually got, let's say you've got the project constructed, you've got your buildings in place, you've got all of that underground infrastructure in place. You're able to capture that information as part of the model. And again, the beauty of that is when you do go to do your operations and maintenance, or when you do go to dig up something, you know precisely where all that utility information is. There's metadata built into that. So you can tap on that, you can see exactly what that utility is, and the condition of that utility, if you've embedded that information into it, if it's been visualized, if it's actually been touched with a pole, you know exactly the elevation, you know exactly the condition of it. That can all be embedded into it. So one of the things that, if you're on the FHWA EDC summit last week, they talked about capturing data once and reusing it many times, and that couldn't be a truer word here, because what that means is once you have that digital information, you don't have to go post-holing or running GPR to find out where your utilities are. All of that underlying data is built into that 3D model. So that can also be used for very powerful visualization tools, and that's exactly what we're looking at here. But they're not just pretty pictures. There's information that's built into all of these, or embedded into all of these data sets, that can be utilized as part of that operations and maintenance aspect. So we also see the digital as-built as a data aggregator. So, how do we better utilize the data-rich point clouds that many DOTs are capturing around the country? What they're doing is capturing highly accurate, digital as-built information of assets, utilities, sending them down the road, sending equipment down the road to capture those point clouds. But what if we could overlay those point clouds with your new digital design? So there's power in that, because you can see how they're interacting with each other. You can see, obviously, look for clashes, and that really truly is the convergence of your physical and digital worlds, because you have both of those designs, or you have your digital design and your as-built information combined together in one location. And obviously being able to see the intersections of those, being able to analyze how those two different models are working out together or interacting with each other, are going to help with your future designs, as well as obviously once the project is constructed. So we talked about connectivity facilitating an informed workflow. So let's say, for instance, we wanted to select a model and we wanted to be able to visualize that data in the field. So again, this is the digital as-built. This has some of the information incorporated into it. It has the intelligence built into it that's being used through the construction lifecycle. But what if we could actually visualize that in the field and then be able to use that as part of the construction project? And this is a real project. Again, we're leveraging our technologies and our European expertise to show you a project where we have all of that information that's built into a model. It's all been mapped. We have the utility information that's built into the designs, and there's metadata associated with all of that, and then the ability to actually not only visualize that in the field, but as you can see here, we can take measurements, we can do observations. And the beauty of this is, because of that connectivity, the devices that are in the field are actually referencing that data that's stored in your digital as-built. So this is not just a single snapshot or whatever. This is part of that living model that we talked about, and they're able to visualize that, interact with it, and then improve the efficiency of an actual constructed project. And of course, all of that then gets bundled into your digital as-built for the actual, once the project is constructed. So how do we get there? How do we achieve the digital as-built? That's really the last sort of part of this discussion here. So Trimble has been building out their technology portfolio around what we're calling our connected construction vision. And fundamentally, it's built around using a 3D model at the center of this diagram here, and then ensuring that every single piece of equipment and every single sort of interested entity has access to that 3D model. So by doing that, that means that you're able to disseminate that model throughout the entire construction lifecycle. And it's the same model that was used in planning and design, in your construction phase, and then in your maintenance and operations. And it can only really do that by the tools that we're essentially talking about here, by connectivity, by having machines being able to read and to capture data from the field and then send that back to the model, because all of that then is what's feeding into the actual digital as-built, which then becomes your sort of resource for your operations and maintenance. So let's consider a standard BIM workflow, and really I would consider the tools that are required to get there, and that's really what Trimble is building out with their technologies. If we're looking at a standard workflow, we need to map your existing conditions. We need to bring in your basic terrain models, point clouds, whatever you've got. You then need to design your new infrastructure. Then we need to be able to visualize that, and of course, very sophisticated visualization tools that we've been touching on previously enable that process, enable that decision-making process, because you're able to visualize it not only in the office, but also out in the field. So contractors are then going to take that model, build from it, use it for planning, for stakeout, and for machine control. But of course, as we mentioned before, they're also going to be capturing data from that field, from the field that's going to be fed back into the model. If changes need to be done, and again, this ties in with the connectivity, who's going to be making a change, who's going to approve that? You need to be able to update those discipline models based on feedback from the contractor or from the field. And that's really what does start to create the truly intelligent as-built. And of course, because all of that intelligence has been built into the model, then that's going to be a far more sophisticated tool that can be used for your operations and maintenance, for those IoT devices, for your autonomy that we all talked about. But even at its core, just being able to use that to know essentially where your road parameters are, where all of your utilities are. Again, having access to that, there's a lot of value for sure. So we're talking about the tools that Trimble is essentially help building to get you there. And one of those is really going to be building a sophisticated common data environment for all infrastructure stakeholders. That needs to be a single source of truth. So that visualization that we were looking at before needs to be able to visualize that data and ensure that it is the latest version, and everyone has provided input to that. And that's really can only be done with an object-based 3D model. So what that means is you're facilitating continuous data connectivity. In other words, you're only sending updates, you're not sending just a file-based approach. You're able to constantly update that model with the latest information from design or from the field. And the beauty of that is, again, we're only sending updates, you're not sending entire models or parts of a model. So one of the things that we've understood is relevant or important is being software agnostic. So we're looking at platforms that enable stakeholders, pretty much everyone that's involved, to maximize the use of their existing hardware and software. We don't want to replace that. We want to enhance what you're already using, leveraging your experience to be able to build that intelligent digital as-built. And of course, you can only really do that by having a platform that doesn't really lock you into a new format. So why do we want to do a shared model? We talked about this living model approach. The benefit of having that shared model means that it's the same model that goes throughout the whole life cycle. And that's that same model that was used for planning and design. So the collaboration between both the office and field, between different parties, means that you're able to have a better design in the very first part of the process. That also enables more efficient construction because of that connectivity that we've already talked about a number of times. Being able to ensure that the machines are using the latest model, being able to ensure that they've got more intelligence by providing tools on those machines to be able to use more advanced models and be able to get a better product. And of course, having that final design, having so much more intelligence built into it, that does become the digital twin, which is basically your digital as-built that's been used throughout the entire process. So we want to talk about facilitating data flow. And again, the benefit of that means that contractors are able to get greater insight into the project, provide input on that latest design. And then also from an owner standpoint, even if they don't want to have a input in the design, they just want to be able to see what's happening by having access to tools where they can see what's happening to the data, who's touched it, when it was modified, if something goes wrong, where was that, where was the file that went in there that caused that issue, being able to identify that, but then also being able to control who sees what and when. There's really lots of value by facilitating that data flow, and lots of the Trimble tools that we're creating now are built around this seamless data flow between office and field, but also between devices and softwares. So that's really the next slide, and that's touching on our software agnostic approach. And that's, again, the benefit of using a software agnostic approach is it removes the barrier of proprietary formats. By having a agnostic approach also means you need to be able to get that data from your existing programs. So we have software connectors essentially that enable essentially transfer of data with no loss of data fidelity. In other words, you can make changes in your design software that's effectively communicated back to your single source of truth, your common data environment, which again is what everyone else is going to be utilizing it. But the benefit is you get to keep all of your software and designs in your own package and leverage that experience. But no, rest. You can rest and be okay with the fact that you've got all of that data in that one location. And then we'll continue on a little bit more. So we talked about connectivity enabling effective communication. It can only really do that by multi-user collaboration on a single model. So all of those connectivity aspects we talked about before, access to the model across multiple devices. So across multiple mobile devices, platforms, we have tools that enable access to that. And of course, they're leveraging all of the information that's stored in that single source of truth. And then it's the communication between all of those parties that really does help facilitate that effective collaboration and communication. So we're getting close to the end of our presentation here, but of course the end goal here is having a digital as-built that can be used for your operations and maintenance. And as touched on before, it can only really do that if it's got all the intelligence built into it. The benefit of having that information or having a model that has everything tied together means everything is connected, which means that you know exactly where your bridges start, your roads end. But the benefit of that too is that that's what's utilized in the actual operations and maintenance, and then also what your IoT devices are leveraging as well. What that means is, and the result is you have a better understanding of the constructed project, which means you have reduced downtime and increased efficiency of use. So quick wrap up here then, essentially the benefit of the digital as-built. So having continuous visibility into the model, collaborative elements around that, field connectivity, as we've touched on, controlled access, being able to see who does what and be able to see who has access to what. The 3D model integration that we've talked about, that single source of truth, that critical aspect of having everything together in one location. Obviously having the complete design information all in that one location, and of course that's essentially controlled by that common data environment. So as you can see, there's a lot of value by having everything together in a digital as-built. This presentation was really to give you a bit of a teaser as to what we're doing. We're going to have follow-up presentations as well. I know Doug's going to touch on that in a second, but hopefully this gives you a bit of a quick idea of what the benefits of applying a 3D construction workflow are, because of that 3D digital as-built and all of the intelligence that's associated with that, but more importantly, how it relies on everything tied together and everything being connected and utilizing that 3D model. So I think that's about it from my end. If you're there, Doug, I believe I can hand this back over to you.
Take a breath, my friend. Have some water. That was really intense, and you did a great job. Thank you. So this recording is going to be made available for everybody, as well as the slide deck. And just to kind of highlight, the next in the series that we're going to do will be solutions more specific for contractors. And for everybody that's attended, we're offering a 1-hour free consultation where we will look at your projects and look at your models and have a discussion about that and about digital as-builts and some of the things that we could potentially be doing to add value to your organization and then your deliverables to your customers. And to Scott 3, we will be back to you with an answer to your very good question. And thank you for sending it. For now, we will wrap it up. Thank you all for attending. Have a happy and safe holiday, and we will be picking it up sometime mid-January after the first of the year.